Hello there. We're looking at chapter 8, surface area and volume. Today we're looking at 8.01. It's a review of surface area and volume and all the formulas that we have studied up till now. Basic formula is area of a square, rectangle, triangle, a trapezium, parallelogram, rhombus, a circle, and the composite figures that we're looking at. Let's quickly review the area of a cylinder and the volume of a cylinder. So let's look at the surface area of a cylinder. We have the the circular end discs of the cylinder. So we have these two cross-sectional areas, these two surface areas. Obviously, they are pi r square, and there are two of those, 2 pi r square. Plus, uh, we need to visualize this rectangular section which is wrapped around the cylinder. So this section which I have just drawn, it's a wrap around on the two circular discs on the end. So once you unwrap these, you will end up getting a rectangle. Now that rectangle, the length of this rectangle, you'll appreciate that this circumference of the circle becomes the length of the rectangle. And obviously this height, which is the height of the cylinder, becomes the width of this rectangle. So you will see that the area of the surface area of this curved surface is nothing but the area of this rectangle, which is 2 pi r h. So if I add 2 pi r h to this one, I'll get the surface area of this cylinder. So that's the formula that has been given here. Obviously, the volume of the cylinder is the cross-sectional area of this cylinder, which is the circle area. That is, volume is equal to pi r square. That is the cross-sectional area multiplied by the height of this circular prism or the cylinder. So pi r square h would be the volume. One important thing to note in this chapter is we should be able to draw sketches quickly. You will need a bit of practice. Most of you do. Please get into the habit of drawing the sketches quickly, because it will help you visualize the solids, and it will be easier not to make a mistake or miss a surface when you're calculating the surface areas. Okay, so let's take two examples I've got here. The first one being a solid which has a cross-sectional area of a sector. So this section is the sector that I'm referring to, correct? Now, let's talk about the prism, and we're talking about the cross-sectional. Or let me call it cross-sectional area. So a cross-section is basically along the axis. If in case you take the cross-section across the axis of the prism, you should get the same cross-section. So it's like an extrusion which has the same cross-section along the length of the solid. So in this case, the cross-sectional area is this sector, which is the same right through this prism. Now here we have the area of the sector, which happens to be the two ends. We'll need those when we are calculating the surface area. We need the area of the cross-section, which is the area of the sector, when we're calculating the volume. Okay, so let's calculate the area of the sector. Now, let's appreciate that this is only a 70-degree sector. If this happened to be a 360-degree sector, then it becomes a full circle, and then the area of that circle is pi r square. Now r being 6 centimeters, so pi 6 square. But in this case, we only have a portion of the whole circle, and the portion is 70 degrees out of 360 degrees, and multiply that by pi 6 square, the area of the circle, we will get the area of the sector. correct? Now this is being an area and the units are centimeter square in this case. Now to find the volume of this solid, we will find the cross-sectional area multiplied by the height or the depth or the length, depending on the terminology that the question uses. You will be able to identify this unit. So the cross-sectional area is 70 out of 360 pi r square, pi 6 square, and the depth in this case is 8, so multiply this by 8. Obviously calculate this using the calculator, and since this is a volume, all the units are aligned, centimeter and centimeter, so we should be able to get this in terms of centimeter cubic centimeters. Surface area, SA, we accept that as a notation. If in case you write that in the exam, that should be fine. Surface area is the two sectors, the front and the back. So 2 times 70 over 360 into pi 6 squared plus. Now you will see this this cross section here, or this rectangular surface here. We have one on this side and another one on this side, which you don't see. Obviously you can visualize there's a section there. So I need to find out the two dimensions of this rectangle or a square. Is it a square? Let's find out. This is 8, that length, and this one is obviously the radius, which is 6. So this is a rectangle of 8 by 6. So this is 8 times 6 times 2. Let me change the color. So this is 8 times 6 times 2, because there are two of those. I've accounted for the two of the sector, the front and the back. I've accounted for the two rectangle sections, surfaces on the sides. Now there's one more that, if you can point out which one that would be. Yes, correct. This one with the curved surface here, this curved surface, and the one that is along the depth of this prism. So this curved surface is again not a complete circle, like in the case of a cylinder we had. In the case of a cylinder we had 2 pi r and then the h. In this case I only have a part of the circle, and that part again is the same fraction as 70 over 360. So we can write this one as 70 over 360 of the 2 pi r, which is 2 pi and 6 is the radius, right? And if I open this up, I'll get a rectangle of 2 pi r 70 over 360. That is going to be this length, and the other dimension will be 8. So multiply by 8. And since this is surface area, all the units are aligned, the same units. This would be centimeter square. All right. If any questions, you can post questions on the Teams, and we'll go through this again if need be. Let me move on to the second example. Here again, we are to calculate the surface area and the volume. The volume, we'll notice that we have a prism of 14 by 14 by 6, right? And there is a hole, that means this section has been taken out. So I can pull out that section from the total volume. That's the simplest way to do this. So volume of this solid is 14 by 14 by 6, correct? And take away the cylinder that has been taken out. The cylinder here, the radius of the cylinder is 4. So I have pi 4 square, pi r square. What is the height? So we need to note that this one is not going through and through the solid prism. It's only going up to a certain depth of 4 centimeters compared to the thickness of the plate or thickness of this prism being 6. So this is only going up to 4. So this is times 4. Obviously use the calculator, find this, and this should be centimeter cube because all the units are in centimeters. Please ensure that you are checking whether units are aligning. if one of these is given in millimeters, you might end up taking that as centimeters and end up getting a different answer. Okay, let's look at the surface area. Surface area, let's look at this quickly. We have a prism, so we should have 6 faces. Make sure you remember and account for all the faces. Then look at the intricacies here. We have a cylinder that has been pulled out that gives me a curved surface here, right, which is going right around, and the bottom face, that is a circle, but then in the top there is nothing, so this is an empty hole. So if I don't account for the bottom and I take that as the top face, so literally I can presume that the bottom face is aligned with the top face, then I don't have to worry about removing the circle from the 14 by 14. Oh, that makes sense what I'm trying to say. Or if you would want to do it, remove the circle from the 14 by 14 and then add one more at the bottom, but depends on how you visualize this. So let's do this one. I'm actually going to do 14 by 14. How many faces are there? One at the top, one at the bottom, so times 2. So I've accounted for 2 faces for a prism. I have to account for 4 more. Let's notice that this is 14 and this is also 14. So this is a 14 by 6, 1 face, 2 face, 3 and 4 faces. So 4 times 14 times 6. So I've accounted for the solid prism. I have to account for this hole. Now, since I didn't take away the circle from the top, I have to account for the circle at the bottom. So that will be compensated over here. What I only have to account for is the curved surface. In this curved surface, like in the case of a cylinder, this is going to be the circumference of the circle, radius being 4. So 2 pi into 4. And the height, or the depth in this case, the terminology again, I spoke about that earlier, is 4 centimeters. So 2 pi into 4. So 2 pi r into 4. The 2 pi into 4 into 4 gives me the surface area of that curved surface. And just double check, am I missing something? 6 faces are here, 4 and 2, 6, and I've counted for the curved surface. It's all good. Centimeter square. Okay, you have 8.01 exercise to complete, and please, as I requested earlier, please draw the sketches. It might look atrocious if in case you don't have enough practice now, but then by the end of the exercise you will draw beautiful sketches, and then that will make it easier for you to solve difficult problems later in the unit where you're looking at practical applications, and it will help you visualize these problems as well, so you won't miss out on surfaces to add up and your answers will be correct. So best of luck. If you have any queries, please post it on the Teams and we'll take it from there. Thank you so much.